This is exam 3, page 3 to 4, section 2, and this is problems A through F. And the question is, let f of x equal this equation, and then equal these, and then the first part is find both f of x and f double prime of x. So f prime of x is going to be negative equals negative 3x squared plus 6x plus 9, and then f double prime of x is going to be negative 6x plus 6. That's A, and then B is find the critical points. So what we're going to be doing is setting the f prime of x equal to 0, so negative 3x squared plus 6x plus 9 equal to 0. And then we're going to factor this. So I thought, what does negative 3 multiplied by 9 is negative 27. So what multiplies to negative 27 but adds to positive 6? And then the values that I got were negative 9 and 3. So then this becomes negative 3x squared plus 9x, and then minus 3x, and then plus 9. And then from there, you can factor even further, and then you'll end up with negative x equals negative 1 as a critical point, and then you'll have x minus 3 equals 0, and that means that x would be 3, positive 3. So these are your critical values. So at negative 1 and 3, and then find for C, find the intervals on which f of x is increasing and the intervals in which f of x is decreasing. Use the first derivative test to determine, and classify the critical points from part B as max, min, or neither. So we're going to make a sign chart. So I started with f prime of x, and then we're going to draw like a little arrow. And then our critical values are negative 1 and then 3. So then we're going to choose values in between each of those and evaluate. So I'll do f prime of 2, negative 2, and then f prime of 0, and then I'll do f prime of 4. And then when you're evaluating these, it'll be f of 2, prime of 2, negative 2, and then that's going to be a negative, and then f prime 0 ends up being a positive when you evaluate it, and then f prime 4 ends up being a negative. So now we know the way the graph moves. It'll go negative, positive, then negative, meaning that it'll go this way, positive, and then back to negative. So right here, we can see that from negative 1 to 3, it's positive, and that means that it will be increasing. F of x will be increasing. And then these are also good to know. These are negative infinity. That's negative infinity, and this is infinity, or positive, whichever one works. So when you're evaluating when it's increasing and decreasing, increasing, decreasing on these two. So increasing, you're going to have from negative 1 to 3. And then decreasing, you're going to have negative infinity to negative 1, negative infinity to negative 1, union, and then it'll be 3 to infinity, 3 comma infinity. So that's where it is increasing and decreasing. And then to find our maximums and minimums, obviously we can see that this is probably min, this is probably max, and so on. But we need to find the y value, so we're going to plug in, make a little table with the critical points. It'll be x, and then this is going to be the original f of x equation, so the one from the top. And then we're going to do our critical values, negative 1, and then 3. And then if I plug negative 1 for x for each of this, for this whole equation, we end up with negative 32. And then if we plug in 3 for x, we're going to end up with 0. So this y value tells you and shows you that the max is going to be at x equals 3, and then the min, because this is the smallest number, and then this is the biggest, technically. So the max is at, it's going to be at x equals 3, and then the min is going to be at x equals negative 1. So that's all C. And then D is find all of the possible inflection points. So for D, when you find the inflection points, you're going to use the second derivative. So our second derivative equation is double prime of x equal to negative 6x plus 6. And we're going to do exactly what we did earlier, and we're going to set it equal to 0. And then for this one, we can kind of just like move it around. So this will become 6 equals negative 6x, and then we'll divide by negative 6. And then it'll be x equals negative 1. So an inflection point is going to be inflection at x equals 1. And then we need to do the same thing where we plug it in to the original f of x. So when you plug in negative 1 for f of x, so it'll be like this. It'll be f of 1, and then it's going to be equal to, and it's going to be negative 1 cubed, and then plus 3 negative 1 squared, and then it'll be plus 9 negative 1, and then it'll be minus 27. And when you get your answer for this, it's going to be negative 16. So the y value for the inflection point is going to be negative 16. And then we'll move on to E. So for E, let's see. Find the intervals on which f of x is concave up and the intervals on which f of x is concave down. Use the second derivative test, determine which of the possible inflection points, etc. So we're going to do the same thing for E that we did earlier, just with the second derivative. So we're going to go E, and then we're going to do what we found earlier was our inflection point was negative 1. Correct. Let's double check. Oh. Our inflection point is 1. Interesting. Oh yeah, the negatives here will cancel. And then you'll end up with positive 1. So your inflection point is 1, not negative 1. Sorry. Good thing I double checked. And then what we're going to do is make a chart. It's going to be f double prime of x, and then our inflection point, or possible inflection point, is at 1. So we're going to do again, it's negative infinity, and then infinity. What we're gonna do, I'm gonna do f double prime of 0, I'm gonna do f double prime of 2, and then if you evaluate these, put them into the equation, f double prime of 0 is gonna be 6, and then f double prime of 2 is gonna be negative 6. So now we know that f of 0 is going to be positive, and then f double prime of 2 is going to be negative. So now we can see if it's positive, this will be concave up. This little section right here, and it's going, the second derivative is negative, that means it's going to be concave down. So our, let's say intervals, our intervals of concave up are going to be from negative infinity to 1, and then concave down is going to be 1 to positive infinity, or just infinity. So then we also know from this calculation earlier that our inflection point on the graph is going to be at 1, negative 16. This is important to note for when we graph it. And then now we're on the graphing part, so we're going to go over here. I made a little graph. So first we need to figure out, this is f. We need to figure out the x and y intercepts. So the x-intercept, I guess I could do it right here. X-intercept. This is going to be equal to f of x, which is going to be equal to negative x plus 3, and then it's going to be x minus 3. And then it's going to be squared from here, and then it's going to be set equal to 0. And then if we solve, we're going to get x equals negative 3 and x equals 3. So then the 2 points are going to be negative 3 comma 0 and then positive 3 comma 0. That's going to be our x-intercepts. And then for our y-intercept, we'll do it over here. For the y-intercept, it's going to be f of 0. So if we do that and we plug in 0 for the x's, we're going to get negative 0 plus 3, and then it's going to be multiplied by 0 minus 3 squared. And then if you evaluate that, you're going to end up with negative 27. So then you know the point for the y-intercept is going to be 0, negative 27. Now that we have all this information, we can start to graph. I'm going to do a different color. So first, we're going to plot our points. Our x-intercept we just figured out is at negative 3, 0. So this is negative 3, 0. And then it's also at positive 3, 0. And then we also figured out that our y-intercept is at 0, negative 27. This is going to be 10, negative 10, negative 20, 30, negative 40, and so on. So our negative 27 is going to be about here. That's our negative 27, and that's our y-intercept. And then we figured out earlier our local max. Where did I put it? Oh, our local max is going to be at 3, 0. So it's going to go, or 0, 3 is what I meant. So that's already there because it was also found as an x-intercept. And then our local min, though, is not on here. It's negative 1, 32. So negative 1 is right here. And then 32 is probably going to be around here. And then we know that it's going to be concave up from negative infinity to 1. So it should be going this shape, and then it'll go concave down from the other interval of 1 to infinity. So then you connect it, and have a sort of crazy shape on the board. And then this is gonna have to cross 3. Oh, I almost forgot. We also have our inflection point at 1, negative 16. That'll be around here, so it's about right where it's gonna cross in the middle, where it changes from concave up to concave down. And then it's gonna bounce off this because this is the max, the local max, and it's the x-intercept, one of them. Okay, this looks a little janky, but you get the point.